All right, ladies and gentlemen, here we go. Let's do project number 3, types of energy. So you guys are busting through this course, which is awesome to see. And anyways, just a quick thing. Let's go over the types of energy. And like always, I'll do a little background just to make sure, clarify any misconceptions you guys have, and to cover some of the basic material that you will need to understand in order to do this project. Okay, so project number 3, we're going to be looking at the different types of energy, and I want to make sure you guys understand this. There's a lot of different types of energy. There's 2 forms of energy, though, that I want to go over. So we have kinetic energy and potential energy, and they're both they're different and they're important. Okay, so kinetic energy is energy of movement. It's the object is moving, whatever it is that we're looking at is moving, and that would be considered kinetic energy. However, potential energy is that stored energy. Let me kind of model this. So here, I don't want that. Here, let me see. Okay, so let me say that here is a little hill. Okay, like so. Okay. Let me just fix one thing now. Okay, let's do that again. So here we go. So right here, let's say that I have a little snowball thing that I've made, and here I am applying a force onto it, and I'm pushing it up the hill. Which type of force is that? Well, we can say that is kinetic energy because it is moving. Okay, what type of chemical energy would it be? It's probably mechanical energy. Okay, so it's an object isn't moving, it's an applied kind of force there, mechanical energy. But let's say that we have it right here and I stop to take a little breather. What type of energy is now that? Well, we would say that that is potential energy. And why is it potential energy? Well, it could fall back this way, or it could fall down this way. And so we can see that there is some potential energy there because it's a high state of energy. There is this amount of energy left available, and we'd call that your potential energy. Okay, and so we're going to look at each one of these different examples here today as we're going through this. All right, so let me go back to present. So part of when we're looking at energy, we want to understand that there is a law here, and it's called the law of conservation of energy. And basically, the law of conservation of energy states that energy cannot be created nor destroyed. And when we're looking at that, we know that systems, there's different types of systems. We can have an open system, a closed system, or an isolated system, and each one of those will follow the same law. But anyways, open system, energy and matter are exchanged with the surroundings, and so we see that energy and matter are lost throughout this in an open system. In a closed system, though, we would see that energy is exchanged but not matter. Matter will stay there. And then if we have isolated systems, both of them are not exchanged and they will stay in there. The hard thing to test these is it's hard to make an isolated system where that amount of energy that we have in there stays there. Most of the time, it's an open system where we have both of them being lost. And so it's hard to really see this law in action unless you could really see an isolated system. But it's there. When we're looking at some different types of energy, we can see that temperature and heat will impact energy. Okay, so we know that heat is the flow of energy from a higher temperature to a low temperature. Okay, so we know that heat will try to make what we call equilibrium. And so if there is a high temp mixed with a low temp, it's going to try and make those equal. And so the question is, well, how is heat transferred from different objects? And it happens in 3 different ways. We can have conduction, convection, or radiation. And this diagram kind of shows that. So we have convection, which is shown right here. Conduction is from one object to the next. And then you have radiation, which is not the same as convection. Okay, a little different. Okay, and so when we're looking at this, we can actually use energy and use less energy by using machines. So machines will lighten the load, if you will, on the amount of energy and work required. And so when we're looking at this, you can see that levers are an example. You have inclined plane, screw, wheels, wedge, pulley, some different things there. Okay. All right. So what we're going to be doing in this lab today, let me pull it up, is we're going to be looking at a virtual skate park. Okay, and this is the model or the simulation you'll be using here. But if you look at this, it'll tell you exactly what to do step by step into doing this lab. So, so for example, click on the playground. So we're going to click on playground there. We're going to open that up. And it says to explore and stuff, so you guys can explore that around and things. See the different stuff you can do, like so. And so if I stick her on that, what's going to happen? Oh, what if I stick her right there? Ah! Okay. And so anyways, you can play around with that a little bit and answer these few questions here. What we're going to do, though, is we're going to start diving into these different options. So we're going to look at potential energy and kinetic energy. So it says click on the intro tab. So if we go back, how do you go? Oh, right here. So intro tab, and let's say we stick her right there. If I stick her, the skater right here, what type of energy will there be? So you can see that's kinetic energy. And even some potential energy there too, right? But anyways, when you're going through that, you'll answer these questions. So using the simulation, describe how you can change the amount of potential energy in the table below. So if we look at that, I'll help you with this first one. If I start her right here, what amount of potential energy is there? Well, the amount of potential energy is just that much, okay? So how can I have the most potential energy? I could have the most by starting her right up there at the top, and we can calculate that, okay? But if I start her down here, we can see we have less potential energy, okay? And I can actually turn these on. I don't like that. But anyways, you can see the potential and the kinetic. So let's look at this. So we have high potential, lower potential, and then we have kinetic energy as movement is occurring. And we have potential, kinetic. So how do I make the most? It's by putting her up there. Okay? So play around with this lab to answer these different questions. Right here, you will put her in different locations to see what happens. Make sure you have evidence to back up your claims that you make. Okay? And then next one, you'll be looking at speed, potential energy, and kinetic energy. You'll be looking at some friction and how friction will impact that as well. If you guys have any questions, please don't hesitate to contact me, and I can go through that one-on-one with you as well. Okay? Make sure you understand these key differences, though.